Hello students, let us today revise your first lesson of your math. And in your first lesson, one question is generally coming in most of the years, and that is proof of irrational number root 2, root 3, root 5 like this. So today we'll discuss root 5 is an irrational number. Okay, so how to start the proof? First of all, you have to take this as a case of contradiction. Okay, suppose root 5 is rational. Suppose I have taken into consideration, I have not taking this one as a fact, and I am not obeying this in this way, and that's why I have taken the just opposite to that fact, and I have to prove whether my taking this fact is right or wrong. Root 5 is rational. So every rational number can be written in P by Q form. You know it. So I can write root 5 as P by Q. Okay, because any rational number can be written in P by Q form. Okay. So taking square, now make it square to remove the root over, and this is the condition. Q is not equal to 0 and P and Q have SCF 1, means no common multiple of both of them, P and Q. Okay, so taking square, squaring both sides, root 5 square will be P by Q whole square. Okay, taking square both the side. In the next step, root 5 square, how much? 5. This will be P square by Q square. Okay, so if I will take Q square to this side, it will be 5Q square equal to P square. So P square is a P square is a factor of 5. From this value, I can say that P square is divisible by 5. I can write, because 5 into Q square is there. So whatever may be the value of Q, it can be divisible by 5. It is clear from this term. So I can write here P square is divisible by 5. So I can write, hence I can write P is divisible by 5. P can be divisible by 5. Because if 9 is divisible by 3, then 3 is divisible by 3, because square root. If 16 is divisible by 4, then square root 4 will be divisible by 4. Okay, 16 is divisible by 2, then the square root of 16, 2 will be divisible by, if 4 is divisible by 2. In this way, I can write here P square is divisible by 5 from this one, this line. I can write P is divisible by 5. Okay. Let's come to the next step. So remember the steps, what I am writing step by step. If P is divisible, so I have write let P equal to 5n. If p is divisible of 5, I can write p equal to 5n. But n is an natural number. So p square will be how much? 5n whole square. Square of this one is square of this one. That means p square equal to 25n square. P square is how much? 5q square. So put the value of p square, 5q square equal to 25n square. Where I have got this line, I have a value of p square in q square form. What I am going to prove? I have already data that p and q have SCF 1. It means p and q have no common multiple or common factor other than 1. Okay. So I have to prove that sentence as wrong. So by this line, I have already proved that p is divisible by 5. P has a factor of 5. Okay. Now I am going to prove q is divisible also by 5. Then what I can conclude? Then p and q both are divisible by 5. P is a common factor for p and q. 5 is a common factor on p and q. Okay. So at that point, I can conclude that p and q can never have SCF 1 because they have common factor 5. So I can prove wrong this sentence there. So at that point, I can take the assumption as wrong. So I have what I have taken here is wrong. Then that means the reverse is right. So it is not a rational number, it is a rational number. I can conclude there. That's why I am taking this sentence here. This line here. Okay. So I have to prove q square equal to 25n square by 5 by 5 here. So q square equal to 5n square. So I can write here q square is divisible by 5 because q square is 5n square, multiple of 5. So I can write here q square is divisible by 5. Hence q is divisible by 5. Now see this one and this one. Both p and q are divisible by 5. Okay. So both p and q are divisible by 5. So I can conclude that p and q I have taken p and q have only SCF 1, but here I can conclude that at least SCF is 5. From this above data, my starting assumption is wrong. Okay, this is the assumption I have taken in the beginning. Hence I can start here. Hence the assumption taken in the beginning is wrong. So root 5 is not an rational number, not a rational number. It means root 5 is an irrational number. Root. So in this way, you can conclude it in a better way. You have to write so many things. So you have to remember the steps also.